All right, hello everyone. Today we are going to wrap up our discussion about the immune system. And we're going to start by doing that by quick talking about immunity. So, in the last video, we talked a little bit about how the immune system works, how it gets broken down into three lines of defense, and specific mechanisms that our body uses to try to protect us from invading pathogens or things that are trying to make us sick. But once we interact with something, we're hoping that we can be safe from it in the future. Once we see it once, we want to make sure we won't get sick from it again. And that is this idea that we talk about immunity. And there are two types of immunity that we can find. The first type is active immunity. And this is more what we consider long term immunity. So, this is hopefully something that's going to last us for most, if not all, of our lifetime. So this is naturally acquired through memory T and B cells. So in the last video, we talked about our lymphocytes, our T and B cells. Two types of those are going to be memory cells. These are basically, their job is to remember when we see something that poses a danger to us. So they're hopefully going to be able to see, okay, we've seen this before, we know it's bad, so we can start a response up and make sure that this thing gets dealt with before it causes too much damage. So they remember pathogens that we've been infected with. They help us to remember. We've seen this before. We know how to deal with this. So this response, the second time we see it, is hopefully going to be faster and more efficient than the first time. The first time you see a pathogen, our body is still recognizing it. It may be unsure. Is this something we need to be really worried about? It may kind of slip under the radar for a bit, but the second time we see it, we're going to be, okay, boom, we've seen this before. We can really get our response started up for this. So this can be artificially acquired through vaccines. So you may have heard of vaccines before. They're very important for helping us to build up an active immunity to things that we have not interacted with before. Because there's some diseases out there where if you get it, it can quite possibly kill you the first time that you get it. So the whole idea behind vaccines is that we're going to try to build up an active immunity to a disease before you have the chance to get it. So how vaccines work is it's going to give you a weakened version of a pathogen, and it's going to introduce that to the body. So this is going to be, scientists are going to be able to basically break down a pathogen so that it can't cause an infection in you, or it just looks really similar to what the real thing might be, so that your body can basically see it. Your T and B cells can see it and be, okay, we know this is something bad. We got to be sure in the future that we can build up a response against this. So then if you do interact with this pathogen in the future, the real version, hopefully your memory T and B cells will kick in and say, okay, we've seen this before, we can get rid of this. And that is really the importance of vaccines, is you're being exposed to something before you see the real version so that you have this active immunity already built up. This weakened version, it is important to mention, when you get a vaccine, it's too weak to make you sick. Some people, for example, say that once they get the flu shot, they feel like they got the flu. This could just be a minor immune system response to seeing this weakened version, but it's not going to be strong enough to make you sick, but it is active enough to stimulate memory T and B cells to ensure that you can hopefully build up this long-term immunity to it. The other type of immunity that we can have is something called passive immunity. One way that this could be acquired, it is naturally acquired from someone else. So, for example, a pregnant woman can actually pass on some immunity to different pathogens to their fetus. So, the baby growing inside of a mother, there can be some immunity passed down from a mom to their growing baby, and that's passive immunity. This can also be done artificially by acquiring antibodies from someone who has been infected. So finding someone who has antibodies against a certain disease or pathogen and giving that to someone else to help protect them. And this is actually how doctors treat for rabies in some cases. So we're basically able to take these antibodies that have been made of a B cell, someone else's B cells that have made antibodies against a certain pathogen, and we're able to give that to someone to give them some sort of short-term immunity. The only difference here, as I kind of just mentioned, is that passive immunity is short-lived. It does not last forever. So while active immunity hopefully is going to last for a long time, hopefully our whole life, passive immunity is going to be much more short-term, and it's eventually going to die out. The next topic I want to talk about is a topic called herd immunity. And you may have heard of this idea called herds when we think about large group of mammals living together in a group. However, scientists can apply this to humans because we as humans prefer to usually live in larger groups. We interact with many different people on a daily basis, so we can kind of consider us to be a herd. So in these pictures, we're going to have three different examples here. We're going to have this blue person. This represents someone who is not immunized for a certain disease or pathogen, but is still healthy. A yellow person who's going to be immunized and they're going to be healthy. And then a red person who is not immunized and they're going to end up being sick and contagious for a certain pathogen. Before we hop into that picture in more detail, I do want to mention herd immunity. The idea behind it is that it stops the spread of a contagious disease when a sufficient percentage of the population is immune. So if we have a population, so any of these three groups here, these all represent sample populations. If a large enough portion of them is immune, if we have a large enough portion of people being immune to a disease, that should hopefully help to protect the rest of the people in the population. So as we mentioned on that last slide, vaccines are going to play a really important role in this herd immunity because they help people to get immune without being exposed to a disease. So let's first take this first example. We're going to have most of our population is going to be not immune to a disease, but still healthy. And then we're only going to have 2 people who are not immunized, but are going to be sick and contagious. So no one is immunized, and the contagious disease spreads through the population. So even just a few people can spread. Once this person maybe infects 2 of these other people, these 2 people could infect 2 other people around them, so on and so forth, until a majority of our population is going to be sick with this disease or pathogen. So this is kind of one example. This is where we don't have anyone immunized, and that's an issue for us. In this next population, for example, we have a couple people who are immunized. So this could be either some people have had it before or some people have gotten a vaccine for a certain disease. But still, if most people in the population are not immunized, most of the population is still going to get this disease. So we're still going to have pretty widespread throughout the population. However, in this last example, this represents a population that has built up a herd immunity to a certain disease or pathogen. So most of the people in this picture have built up immunity. They've been immunized and they're healthy. So theoretically, they shouldn't be susceptible from getting sick from these 2 infected people. So in this situation, even though there are a few people who are not immunized in our population, those people should theoretically still be okay. Because if a lot of the people around them don't have the potential to get sick, there's a lower chance that these non-immunized people are going to come into contact with these few contagious people. So this really helps to represent the idea of herd immunity. If most of our population is immune, it not only protects the people who are already immune, but people who are not immune are also protected because they're going to come in contact with less contagious people. So herd immunity can be a really helpful tool for us when we're trying to stop the spread of certain diseases and pathogens. When we're thinking about some of these people who may not be immune, some people choose not to get vaccinated for religious or personal beliefs. Also, younger babies, as soon as you're born, you're not really ready to get vaccines. So babies or younger children are at higher risk population because they can't get vaccinated as early. And then older people, as you continue to get older, you can start to lose some of that active immunity that we talked about on the earlier slide. Even though you may have been immune to something earlier in your life, as you get older, you can start to lose that immunity. So that those 3 groups are going to represent some of those people who may not be able to fight off a disease as easily if they were to interact with a contagious person. Lastly, we're going to talk about some immune system disorders. So just what are some things that can go wrong with the immune system. A general term that we can use is immunodeficiency. So this would describe lacking or slow production of immune cells, such as white blood cells and antibodies. So many people can be immunodeficient for a variety of reasons, but this basically just means that your immune system is not working as well as it should. There's an issue going on here, and your body is not creating enough of these cells in order to properly protect your body. Another type of disorder that you could have is allergies. Many of you probably are allergic to something, and allergies are it's considered to be an immune system disorder. So these are caused by antigens, which in this case we refer to as allergens. And when our body basically recognizes these antigens, it's going to trigger the release of histamines, which leads to inflammation. How this manifests in our body, this could be hives that can form on your skin, could cause your airways to close up. And this is common signs of a more serious allergic reaction to something. You could feel maybe a tingling on your tongue is maybe a more minor reaction. But this is your body basically saying there's this weird thing inside of us and we don't know how to deal with it. So we're going to release these molecules called histamines that are going to basically alert the immune system and say, hey, there's an issue here. We got to try to solve it. If we remember, the two types of white blood cells responsible for releasing histamines are going to be those eosinophils and basophils. So those are going to be the two main types of white blood cells that are going to cause allergies to come about. In order to treat allergies, people are given antihistamines, so directly fighting against this chemical released by our body. And this is going to help us to reduce inflammation. So this might be something like Benadryl. Benadryl is going to be an example of an antihistamine that can help people to deal with an allergic reaction to something. Another type of immune system disorder is something called an autoimmune disease. And this is basically a situation where the immune system attacks its own cells. If we hopefully know, our immune system is trying to keep us healthy from things that are not supposed to be in our body. However, sometimes our body can make a mistake and actually start to recognize our own cells as being dangerous to our body. And that would be when an autoimmune disease is occurring. An example is type 1 diabetes. This is a form of an autoimmune disease. So this is antibodies attacking insulin-producing cells in the pancreas. So insulin is an essential molecule that helps us to regulate our blood sugar levels, and that is created by the pancreas. Type 1 diabetes is basically where our body, for some reason, recognizes these cells in our pancreas as being foreign or dangerous to us. So it starts to attack these cells in our pancreas, and that causes our body to not be able to make the insulin that it needs to help regulate our own blood sugar. Type 1 diabetes, at least, is an example of an autoimmune disease. The treatment for autoimmune disease, there can be a few. There could be medication to treat directly the symptoms. So for type 1 diabetes, in order to treat it, you basically need to get shots of insulin because insulin is kind of essential for regulating our blood sugar levels. So we can basically just give the person what they need, what they're not getting, more or less. Another thing that we can use is something called immunosuppressants. So this is something that suppresses the immune system. In autoimmune diseases, basically our immune system is too active. It is too much on the lookout for things that could be dangerous to it. So we've discovered medicines that are going to be able to basically calm the immune system down. However, this can cause an issue in some cases. Whenever you are on an immunosuppressant, this means that you need to be monitored because this suppresses the entire immune system response and can leave you vulnerable to disease. So when you're taking an immunosuppressant, your entire immune system is going to be a little bit worse. So if you were to get exposed to something that could make you sick, your body probably is not going to be able to fight it off as well. So people who are on immunosuppressants for certain autoimmune diseases need to be really careful to not come in contact with people who could be contagious for different diseases or pathogens, as people who are immunodeficient or on immunosuppressants are going to be much more likely to get a serious reaction to a certain disease or pathogen. Alrighty, so that is going to wrap up our discussion of the immune system. Thank you for watching.